My name is Chad Sosolik, and I'm a professor of physics at Clemson University. A solar eclipse occurs when the moon passes between us and the sun. What does a solar eclipse look like? There is a path, in this case cut through the United States, which is the path of totality. So for those lucky enough to be in that path, you will see the sun completely covered by the moon. That's a total eclipse. For the rest of us, outside of the path of totality, you will have a partial eclipse, where you will see some fraction of the sun covered by the moon. The technical term is that's an annular eclipse, and that is when the sun is blocked, akin to a total eclipse, by the moon. However, the moon is in such a position in its orbit that it's further away, which means the shadow it casts is not enough to block out the sun entirely. And so you see a ring of the remaining part of the sun shining back around the moon. That's exciting to scientists because it gives them a perfect opportunity to study the outer edge of the sun. So unfortunately, we will not have an annular eclipse this year. We had one last year. You can be injured by a solar eclipse. If you look directly at the sun, then the invisible rays, so the ultraviolet and the infrared, can burn your eyes. The safest way is to not look at the sun. So the safest way would be to do it indirectly. If you go in your kitchen, grab a colander. But if you go to NASA's website, you can figure out how to build what's called a pinhole projection camera, which will allow you to cast the sun's image and the eclipse onto a viewing screen or even onto the ground. Prepare yourself and prepare your kids. You don't really have nerve endings in your eye, so people are going to be tempted to stare at the sun, and we don't want anybody getting injured. Scientists are interested in eclipse in general because it gives them a chance, certainly from ground-based instruments, to look directly at the sun with instruments for a time period which is governed by the length of the totality. So in this case, we have twice as long as we did in the previous totality to look at it. Plus, we have better instruments than we had before. Always we're improving. Why is this one particularly interesting? Is because we're actually in a period of solar maximum or high solar activity. So there is a chance we may have a confluence of two events. We could actually have an eclipse and at the same time have something cool happen, like a coronal mass ejection, which is the sun basically burps out a lot of material, which could come flying toward the Earth, and we might be able to see that at the same time. The key here is that you might ask, why doesn't this happen 12 or 13 times a year? Why don't they just cross each other in the sky once a month as the moon goes around the Earth? As it turns out, the moon is actually tilted 5 degrees relative to the path that is the orbit of the Earth around the sun. So if you take two circles, you'll see that if you tilt them by 5 degrees, you get 2 crossing points. That's why I said you're guaranteed to get at least 2 eclipses per year. Now, whether this all happens, aligns over your particular location, or if it happens more than twice a year, just depends then on the paths that these bodies take in those particular orbits. So for instance, 2017, our totality was around 2 minutes. This time it's going to be around 4 minutes. The maximum it can be is about a little over 7 minutes. So we're not in a 7-minute eclipse this year.
Now, where'd you find those cool glasses?
Dad bought them for us for Christmas because we were planning to do this.
Oh, that's awesome.
about 15 more minutes or so. It should be dark.
2:37.
What time is it now?
2:35.